Rain begins during a period when Earth is still settling into the form we recognize today. The planet starts as a molten world with a surface too hot for liquid water. Any water present exists as vapor released from the interior through intense volcanic activity. Over time, the crust cools and the atmosphere becomes dense with steam, carbon dioxide, and nitrogen. As temperatures fall, the vapor begins to condense into clouds thick enough to cover the planet for long stretches. Once the surface cools below the boiling point of water, the first sustained rainfall begins. This is not a brief event. The cooling process allows condensation to continue on a massive scale, and rain falls for an extended period as the atmosphere sheds the water it has been holding. The downpour contributes to the formation of the early oceans, filling basins and depressions across the young crust. The water that collects becomes part of a growing hydrosphere that will eventually stabilize into the oceans we know today. The water itself comes from multiple sources. Some of it originates deep within the planet, locked inside minerals that release vapor during volcanic outgassing. Another portion arrives from space, delivered by water-bearing asteroids during the late stages of planetary formation. As the atmosphere continues to cool, the water cycle begins to take shape. Evaporation, condensation, and precipitation start to operate in a repeating loop. This cycle becomes one of the planet's most stable systems, redistributing heat and moisture across the surface. Over long periods, rainfall contributes to erosion, breaking down rock and transporting sediment. Channels deepen into riverbeds, and low areas fill to become lakes. The landscape slowly shifts under the influence of repeated rainfall and runoff. The planet transitions from a world dominated by volcanic gases and heat to one with a stable hydrosphere and a functioning water cycle. These changes create the conditions necessary for life to emerge. The presence of liquid water, steady temperatures, and a more temperate atmosphere set the stage for the next chapters in Earth's history. When humans began shifting from nomadic hunting and gathering to settled agriculture, rainfall patterns became one of the strongest forces shaping where permanent communities could survive. The earliest farmers didn't choose locations based on abstract ideas of fertile land. They chose places where the timing, amount, and reliability of rainfall made food production possible. In the region between the Tigris and Euphrates, rainfall was modest and inconsistent. The soil was rich, but the sky offered little predictability. Early communities responded by developing irrigation systems that were simple at first, such as shallow channels dug with stone tools, but grew more complex as populations increased. These channels allowed farmers to guide river water into fields during dry periods. Over generations, the networks expanded into a coordinated system of canals, levees, and reservoirs. Managing water became a communal responsibility, and the need for cooperation encouraged the formation of early administrative structures. The earliest written records from this region include tallies of grain and water allocations, showing how closely rainfall, agriculture, and bureaucracy were linked. In the Nile Valley, the relationship between people and water followed a different pattern. Rainfall itself was minimal, but the annual rise of the river acted as a dependable substitute. The floodwaters carried silt from upstream regions and spread it across the floodplain. Farmers planted as the water receded, using the moisture left behind in the soil. The consistency of this cycle allowed communities to plan their agricultural year with remarkable precision. Calendars, surveying tools, and early mathematics developed in part because people needed to track the height and timing of the flood. Even small variations in the river's behavior were recorded, because a slightly higher or lower flood could affect harvests for an entire year. In the Indus Valley, rainfall arrived in the form of monsoons. These seasonal winds brought heavy rains that replenished rivers and supported large agricultural zones. The success of crops depended on the strength and timing of the monsoon, so communities built reservoirs and wells to store water during the wet season. Archaeological evidence shows carefully planned cities with drainage systems designed to handle sudden downpours. Streets were graded to direct water away from homes, and large public baths were supplied by a combination of rainfall and groundwater. The infrastructure reflects a society that understood the rhythm of its climate and built accordingly. Farther east, in northern China, early farmers relied on rainfall to grow millet in the lush plains. The soil there was unusually soft and easy to work, formed from fine particles deposited by ancient winds. Rainfall patterns shaped the agricultural calendar, and communities developed storage pits to protect grain during dry years. Over time, as populations grew, people began diverting small streams and building terraces to capture runoff. These techniques allowed them to expand farming into areas where rainfall alone would not have been sufficient. Across these regions, rainfall influenced settlement density, trade routes, and social organization. Communities in areas with unpredictable rainfall often developed systems for storing surplus food, while those in more stable climates could support larger populations with less risk. The need to manage water encouraged cooperation, planning, and long-term thinking. These traits became part of the cultural fabric of early civilizations. Rainfall also played a part in the spread of domesticated plants. Wheat and barley thrived in areas with moderate seasonal rain. Rice required standing water and spread through regions with monsoon cycles or river deltas. Sorghum and millet adapted to drier climates and supported communities where rainfall was sparse. The distribution of these crops shaped migration patterns and determined which regions could support large settlements. By the time writing, trade, and early states emerged, rainfall had already guided centuries of human decision-making. The earliest towns and cities grew in places where water could be predicted, stored, or controlled. The relationship between people and rain was practical, constant, and deeply embedded in daily life. It influenced where homes were built, how fields were laid out, and how communities organized themselves from season to season. As early communities became dependent on agriculture, rainfall turned into a central concern. People needed to understand when it would arrive, how long it would last, and whether it would be enough to sustain crops. Without written records or scientific tools, they relied on observation, memory, and shared stories to make sense of weather patterns. Over generations, these observations developed into beliefs and rituals that helped communities navigate uncertainty. In regions with seasonal rainfall, people noticed patterns long before they understood the mechanisms behind them. The arrival of dark clouds, shifts in wind direction, or changes in humidity became signals that guided planting and harvesting. These signs were passed down through oral tradition, forming a kind of early meteorology based on experience rather than measurement. Communities used these cues to prepare fields, store food, and organize labor. Where rainfall was unpredictable, rituals emerged as a way to cope with the anxiety of not knowing whether crops would survive. These practices varied widely, but they often shared a common purpose: creating a sense of control in situations where outcomes were uncertain. In parts of Mesoamerica, ceremonies were held at the start of the growing season to encourage favorable weather. Offerings were made at springs, caves, or mountaintops, places associated with water sources or atmospheric changes. These locations were chosen not because of symbolic meaning alone, but because they were tied to the practical realities of where water appeared in the landscape. In South Asia, communities developed traditions around the monsoon. The timing of the rains determined the success of rice cultivation, so people paid close attention to the first signs of the seasonal shift. Songs, festivals, and communal gatherings marked the transition from dry season to wet season. These events reinforced social bonds and helped coordinate agricultural work. Even when the monsoon arrived later than expected, the rituals provided a structure for waiting and preparing. In the Mediterranean and Near East, where rainfall could vary dramatically from year to year, people created practices aimed at encouraging favorable weather or expressing gratitude when rains arrived. These customs were often tied to agricultural cycles. Some involved processions through fields, while others focused on communal meals or shared offerings. The rituals served both practical and social functions. They brought communities together, reinforced shared responsibilities, and provided a way to respond collectively to environmental challenges. In East Asia, early records show that rainfall was monitored closely by rulers and administrators. The success of crops reflected directly on leadership, so weather observations became part of governance. Rituals were performed not only for agricultural reasons, but also as demonstrations of responsibility. Leaders were expected to acknowledge periods of drought or excessive rain and respond with public acts meant to restore balance. These practices reveal how deeply rainfall was woven into political and social structures. Across different regions, rain rituals were shaped by local climate, geography, and agricultural needs. They were not simply expressions of belief. They were tools for managing uncertainty, organizing community life, and reinforcing shared understanding of the environment. People used them to interpret weather patterns long before scientific explanations were available. The rituals helped communities adapt to the challenges of early agriculture, providing continuity from one generation to the next. Rainfall influenced survival, and survival influenced culture. The practices that developed around weather were grounded in observation, shaped by necessity, and carried forward because they helped people navigate the unpredictability of the natural world. As settlements grew into towns and cities, rainfall became a practical concern that shaped how buildings were designed. Early structures were simple, but even the simplest homes had to respond to the climate around them. In regions with frequent rain, builders learned to angle roofs so water could run off instead of pooling. Clay tiles, wooden shingles, and thatch were chosen not only for availability, but for how well they shed water. Over time, these choices created distinct architectural styles tied directly to local rainfall patterns. In ancient Greece, builders used terracotta roof tiles that interlocked to keep rain from seeping through. The angled roofs directed water into stone gutters that carried it away from foundations. This approach was refined in Rome, where engineers developed more advanced drainage systems. Roman buildings often included channels carved into streets, courtyards, and public squares to guide rainwater toward cisterns. These cisterns stored water for drinking, bathing, and irrigation, turning rainfall into a resource rather than a nuisance. In medieval Europe, timber-framed houses with steeply pitched roofs became common in areas with heavy rainfall. The steep angle prevented snow and water from accumulating, reducing the risk of collapse. Builders added overhanging eaves to keep rain from running down the walls, which helped preserve the wooden frames. Gutters made from hollowed logs or metal strips were attached to direct water into barrels. These barrels provided households with a steady supply of water for cooking and washing, especially in towns where wells were scarce. In Japan, traditional architecture developed in response to a humid climate with frequent rain. Wooden buildings were raised slightly above the ground to prevent moisture from seeping into the floors. Wide eaves extended far beyond the walls, creating sheltered walkways and protecting the structure from driving rain. The design allowed air to circulate beneath and around the building, reducing the buildup of dampness. These features became defining elements of Japanese architecture, blending practicality with aesthetic considerations. In regions with monsoon climates, such as parts of India and Southeast Asia, buildings were constructed to withstand intense seasonal downpours. Roofs were often made from materials that could handle sudden, heavy rainfall without deteriorating. Courtyards were designed to collect water, allowing it to soak into the ground or flow into storage tanks. Some cities developed elaborate stepwells and reservoirs that filled during the rainy season and provided water during dry months. These structures were not only functional, but also served as social gathering places. In the Middle East and North Africa, where rainfall was limited but occasionally intense, architecture adapted to both scarcity and sudden storms. Flat roofs were common in dry regions, but they were built with slight slopes to guide water toward collection points. Homes often included internal courtyards with drainage channels that directed rainwater into underground storage chambers. These chambers kept water cool and protected from evaporation, making even brief rain events valuable. As cities expanded, managing rainwater became a matter of public planning. Streets were graded to direct runoff, and early sewer systems were developed to prevent flooding. In some places, rainwater was integrated into urban design. Canals, fountains, and public baths relied on stored rainwater, turning practical infrastructure into civic features. The way a city handled rain reflected its technological capabilities and its understanding of local climate. Rain shaped architecture in ways that were both subtle and far-reaching. The materials chosen, the angles of roofs, the placement of courtyards, and the layout of entire neighborhoods were influenced by how often and how heavily it rained. These decisions accumulated over generations, creating architectural traditions that still define many regions today. Rain influenced the routines of ordinary people long before written records described those routines. In agricultural communities, the sound of distant thunder or the sight of darkening clouds could change the course of a day. Farmers adjusted their work based on the likelihood of rain, choosing tasks that matched the weather. On dry days, they plowed, sowed, or harvested. When rain arrived, they shifted to sheltered work, repairing tools, tending animals, or processing grain. These adjustments were practical responses to the environment, repeated across generations until they became part of the rhythm of rural life. Travelers paid close attention to rainfall as well. Roads in many regions were little more than compacted earth, and a sudden downpour could turn them into deep mud. Merchants carrying goods often waited out storms in roadside shelters or inns, knowing that pushing forward in wet conditions risked damaging their cargo or injuring their animals. Caravans in desert regions timed their movements around seasonal rains, using temporary pools and fresh vegetation that appeared only after storms. Markets and town squares responded to rain in their own ways. In many places, vendors set up stalls under awnings made from woven reeds, cloth, or leather. These coverings offered limited protection, so a heavy rain could shorten the market day. People hurried to finish their purchases before the weather worsened, and sellers packed up quickly to protect their goods. Over time, some towns built permanent covered markets to reduce the disruption caused by rain. These structures allowed commerce to continue even during long wet seasons, reflecting how communities adapted to local climate patterns. Clothing evolved alongside these routines. In regions with frequent rain, people developed garments that shed water or dried quickly. Early waterproofing methods included coating fabrics with oils, waxes, or resins. Fishermen in northern Europe wore heavy wool garments that remained warm even when soaked. In East Asia, people used woven straw capes and wide-brimmed hats to keep rain off their bodies. These items were practical tools for the demands of daily work in wet conditions. Tools and storage methods also reflected the influence of rain. Grain had to be kept dry to prevent spoilage, so communities built raised granaries with slatted floors that allowed air to circulate. Pottery used for storing food often had tightly fitting lids to keep out moisture. In some regions, people constructed elevated walkways or platforms to move between buildings during the rainy season. These adaptations show how deeply rain affected the design of everyday objects and the layout of living spaces. Rain formed social behavior as well. In many cultures, shared shelters became places where people gathered during storms. Work paused, and conversations filled the time until the rain eased. These moments created opportunities for storytelling, teaching, and community bonding. The pause enforced by weather became a natural part of social life, offering a break from routine and a chance to connect with others. Even leisure activities were influenced by rainfall. In some regions, children played games that could only be enjoyed during the rainy season, such as floating small boats in temporary streams or catching raindrops in containers. Adults used rainy days for tasks that required concentration, like weaving, carving, or repairing household items. Across centuries and continents, rain guided the pace of life in ways that were subtle but persistent. It influenced when people worked, traveled, traded, rested, and gathered. These patterns became part of the cultural fabric of each region, passed down through generations as practical knowledge rather than formal instruction. Rain begins with the movement of warm, moist air. When air rises, it cools, and cooler air cannot hold as much water vapor. The excess moisture condenses into tiny droplets that gather around microscopic particles such as dust, salt, or pollen. These droplets form clouds. As more moisture accumulates, the droplets grow heavier. When they reach a point where gravity overcomes the upward motion of the air, they fall as rain. This process is simple in principle but influenced by countless variables: temperature, humidity, wind patterns, and the presence of particles in the atmosphere. Raindrops do not fall in the teardrop shape often shown in drawings. They begin as spheres, and as they fall, air resistance flattens their bottoms slightly, giving them a shape closer to a tiny hamburger bun. Larger drops can become unstable and break apart into smaller ones. The size of a raindrop depends on the conditions inside the cloud and the distance it travels before reaching the ground. Light drizzle forms when droplets remain small, while heavier rain occurs when droplets have more time to grow before falling. The scent that often accompanies the first rainfall after a dry period comes from a combination of natural processes. Oils released by plants accumulate on surfaces during dry weather. When rain arrives, these oils mix with compounds produced by soil-dwelling bacteria. The impact of raindrops releases these compounds into the air, creating the familiar earthy smell known as petrichor. This scent is strongest after long dry spells because more material has built up on the ground. Thunderstorms form when warm, moist air rises rapidly and encounters colder air above. The rising air creates strong updrafts that lift water droplets and ice particles high into the atmosphere. Collisions between these particles generate electrical charges. When the difference in charge becomes large enough, electricity moves through the air in a sudden discharge. The flash of lightning heats the surrounding air so quickly that it expands in a shock wave, producing the sound of thunder. The delay between lightning and thunder reflects the time it takes for sound to travel to the observer. Meteorologists study rainfall using a combination of ground instruments, radar, and satellite observations. Rain gauges collect water in a standardized container, allowing precise measurement of how much rain falls in a given period. Radar systems detect the movement and intensity of precipitation by sending out pulses of energy and analyzing the signals that return. Satellites provide a broader view, tracking cloud formation, storm development, and moisture patterns across entire continents. Together, these tools allow scientists to monitor weather systems and forecast rainfall with increasing accuracy. Different regions experience rain for different reasons. In the tropics, warm temperatures and abundant moisture create frequent afternoon storms. In temperate zones, rain often arrives with large weather systems that move across continents, driven by differences in air pressure. Coastal areas receive rain when moist ocean air meets cooler land. Mountain ranges influence rainfall by forcing air upward, causing moisture to condense on the windward side while leaving the leeward side much drier. These patterns create distinct climates that persist over long periods. Even with modern tools, predicting the exact timing and intensity of rain remains challenging. Small changes in temperature or wind direction can alter the development of a storm. Moisture can accumulate in one area while dissipating in another. The atmosphere is a dynamic system with countless interacting parts, and rainfall is one of its most visible outcomes. Scientists continue to refine their understanding of these processes, using new technologies to study clouds, aerosols, and atmospheric circulation. Rain affects animals in ways that reflect millions of years of adaptation. Each species responds according to its needs, its habitat, and the opportunities or risks that wet conditions create. Some animals become more active when rain begins, while others retreat until the weather settles. Amphibians are among the most closely tied to rainfall. Frogs, toads, and salamanders rely on moisture to keep their skin from drying, so wet conditions allow them to move freely across the landscape. After a storm, their calls often rise in volume and frequency. Many species use rainy nights as their primary breeding window, gathering in temporary pools that form only after heavy downpours. These pools offer a safe place for eggs, free from fish that would otherwise feed on them. The timing of these gatherings is so consistent that entire populations can appear almost simultaneously once the first rains arrive. Birds adjust their behavior depending on the type of rain. Light showers may not interrupt feeding, but heavier rain reduces visibility and makes flight more difficult. Many birds seek shelter in dense foliage, where leaves break the force of falling water. Some species, such as swifts and swallows, take advantage of insects that gather near the surface during rain. These birds alter their flight patterns to skim low over fields and bodies of water, catching insects that have been pushed downward by the weather. After storms, birds often resume feeding quickly, taking advantage of worms and other small creatures that emerge from the soil. Large mammals respond to rain in ways that reflect their size and habitat. Grazing animals often continue feeding during light rain, since moisture softens vegetation and makes it easier to eat. During heavy storms, they may gather in groups for protection or move to higher ground to avoid flooding. Predators adjust their routines as well. Wet conditions can mask scent trails, making it harder to track prey, but rain also muffles sound, allowing some animals to approach more quietly. These shifts in behavior create a temporary change in the balance between predator and prey. Insects show some of the most varied responses to rain. Many species seek shelter under leaves, inside bark, or within the soil. Others use rain as an opportunity. Termites in certain regions begin their mating flights after storms, when the ground is soft enough for new colonies to form. Mosquitoes rely on standing water created by rainfall to lay their eggs. Even earthworms emerge from the soil during rain, taking advantage of the moisture to move across the surface without drying out. These movements create feeding opportunities for birds and small mammals, linking the behavior of multiple species to the arrival of rain. Aquatic animals experience rain differently. In rivers and lakes, rainfall can lower water temperature, increase oxygen levels, and change the movement of currents. Fish often respond by shifting their feeding patterns, rising closer to the surface or moving into areas where runoff brings nutrients. In coastal regions, heavy rain can alter salinity levels, prompting marine animals to adjust their positions until conditions stabilize. Some animals rely on rain as a signal for seasonal movement. In parts of Africa, the first storms of the wet season trigger migrations of grazing animals that follow new plant growth. Birds in many regions time their nesting cycles to coincide with periods when rain brings an abundance of insects. Even small creatures, such as certain species of frogs and insects, use rainfall as a cue to emerge from dormancy or begin breeding. Rain can be a cue, a resource, a challenge, and a moment of opportunity. Each species responds in its own way, guided by the conditions of its habitat and the needs of its life cycle. The basic process of condensation and precipitation occurs on several worlds, but the materials involved vary widely. The conditions of each atmosphere determine what forms, how it falls, and whether it ever reaches the ground. Venus offers one of the most extreme examples. Its atmosphere contains clouds of sulfuric acid suspended high above the surface. Droplets form within these clouds and begin to fall, but the planet's intense heat causes them to evaporate long before they reach the ground. This creates a phenomenon known as virga, rain that disappears in midair. The combination of high pressure, extreme temperature, and corrosive chemistry makes Venusian precipitation fundamentally different from anything on Earth. Titan, Saturn's largest moon, has a cycle that resembles Earth's in structure but not in substance. Its lakes, rivers, and clouds are made of liquid methane and ethane. Methane evaporates, condenses, and falls as rain in a slow, steady drizzle due to Titan's thick atmosphere and low gravity. These rains carve channels and fill basins, creating landscapes that look familiar despite being formed by a completely different liquid. Titan's frigid temperatures allow methane to behave as water does on Earth, supporting a full hydrological cycle built from hydrocarbons. On the gas giants, precipitation occurs deep within their atmospheres. Saturn and Jupiter may produce carbon-based rain under extreme pressure. Lightning storms break apart methane molecules, freeing carbon atoms that fall through dense layers of gas. As they descend, these atoms compress into graphite and then into tiny diamonds before eventually dissolving again in deeper, hotter layers. This process remains theoretical, but is supported by modeling and laboratory simulations. Neptune and Uranus may experience a similar process. Their atmospheres contain methane, and the pressures within their interiors are high enough to compress carbon into solid forms. Models suggest that diamond particles could form and fall slowly through the layers below the visible clouds. These conditions create a type of precipitation that has no parallel on Earth. Some exoplanets exhibit even more unusual forms of rain. On WSB 76b, a planet so hot that metals vaporize, iron may condense on the cooler side of the planet and fall as molten droplets. On HD 189733b, high winds may carry silicate particles that fall as glass-like shards. These environments demonstrate how precipitation can occur under extreme temperatures and exotic atmospheric compositions. Across the solar system and beyond, rain takes many forms: methane, sulfuric acid, carbon, molten metals, and even glass. Despite these differences, the underlying process remains the same. Vapor condenses into droplets, droplets grow, and gravity pulls them downward. This consistency across such varied environments highlights the universality of physical laws, even as each world expresses them through its own materials and conditions. Rain has become one of the most recognizable tools in visual storytelling. Filmmakers use it not because audiences expect symbolism, but because rain changes the texture of a scene in ways that cameras capture well. Water on streets reflects light, creating depth and contrast. Falling droplets soften the edges of objects, giving nighttime scenes a glow that feels natural. Even the sound of rain adds a steady backdrop that can make dialogue feel more intimate. These qualities make rain a practical choice for directors who want to alter the mood of a scene without changing the setting. Producing rain on a film set requires careful planning. Natural weather is unreliable, so crews often use rain rigs, large metal frames with pipes that release water in controlled patterns. The water must fall in a way that is visible on camera, which means droplets are often larger than real rain. Lighting crews position lamps behind the falling water to catch each droplet, creating the streaks that viewers associate with cinematic rain. This setup allows filmmakers to maintain continuity across multiple takes, ensuring that the rainfall looks consistent even if scenes are shot hours apart. Actors must adjust their performances when working in artificial rain. Wet clothing becomes heavy, and cold water can make long shoots uncomfortable. Crews often warm the water to keep actors safe during extended scenes. Microphones must be protected from moisture, and camera operators use waterproof housings to prevent damage to equipment. Rain also affects pacing. Scenes filmed in wet conditions often feel slower and more deliberate, partly because movement becomes more cautious. Characters pause under awnings, wipe water from their faces, or adjust their clothing. These small actions create a sense of realism that audiences recognize from their own experiences. In animation, rain is created through entirely different methods. Artists draw or simulate droplets, ripples, and reflections frame by frame, or through digital tools. The challenge lies in making the rain feel integrated with the characters and backgrounds. Animators study real rainfall to understand how water behaves on surfaces, how it distorts light, and how it interacts with wind. These observations help them create scenes that feel convincing even when the world on screen is entirely imagined. Sound design plays a major role in how rain is perceived in film. The patter of droplets on roofs, the rush of water in gutters, and the distant rumble of thunder all contribute to the atmosphere of a scene. Sound engineers layer recordings from different environments to create a specific mood. A gentle shower might use soft, irregular patterns, while a storm requires heavier impacts and deeper tones. These choices guide the audience's emotional response without solely relying on dialogue or music. Rain appears in documentaries as well, where it serves a different purpose. In these films, rain is part of the natural environment rather than a constructed element. Documentarians often work with unpredictable weather, capturing scenes that reveal how people, animals, or landscapes respond to wet conditions. These moments add authenticity, showing the world as it is rather than as it is staged. Rainfall varies dramatically across the planet, and each region experiences it through its own patterns, rhythms, and environmental pressures. In some places, rain arrives with remarkable consistency. In others, it is rare enough to define entire ecosystems. These differences influence how communities plan their year, manage resources, and respond to changing weather. In the northeastern regions of India, rainfall reaches levels unmatched anywhere else on Earth. Moist air from the Bay of Bengal rises sharply when it encounters the Khasi Hills, cooling rapidly and releasing enormous amounts of rain. Storms can last for days, and annual totals often exceed what some deserts receive in a century. Homes are built with materials that can endure constant moisture, and footpaths include living root bridges that withstand repeated exposure to heavy rain. Daily routines adapt to long stretches of wet weather, with people moving between covered walkways and sheltered communal spaces. In contrast, the Atacama Desert in Chile receives so little rain that some weather stations have recorded no measurable precipitation for decades. The dryness results from a combination of cold ocean currents, stable atmospheric conditions, and mountain ranges that block moist air. Plants and animals survive through specialized adaptations, relying on fog, dew, or underground moisture rather than rainfall. Human settlements depend on water transported from distant sources or extracted from aquifers. The absence of rain influences everything from agriculture to architecture, creating a landscape where even brief showers become notable events. Monsoon regions experience a different relationship with rain. In South Asia, the monsoon arrives each year with a shift in wind patterns that brings moisture from the Indian Ocean onto the subcontinent. The arrival of the first rains is a major seasonal transition, marking the start of planting for millions of farmers. Cities prepare for flooded streets, swollen rivers, and transportation delays. The monsoon provides essential water for agriculture, but it also brings challenges such as landslides, erosion, and infrastructure strain. The season is both welcomed and monitored closely, as its timing and strength influence food supplies and economic stability. In equatorial rainforests, such as those in the Amazon and Congo basins, rain falls throughout the year with only slight variations. The constant moisture supports dense vegetation, diverse wildlife, and complex ecological interactions. Rivers swell and reseed in predictable cycles, and communities living along their banks adjust their activities accordingly. Fishing, transportation, and farming all depend on understanding these cycles. The steady presence of rain maintains the forest environment, influencing soil conditions, plant growth, and the movement of nutrients. Temperate regions experience rain through a mix of seasonal patterns and large-scale weather systems. In parts of Europe and North America, rain arrives with passing fronts that move across continents. These systems bring alternating periods of clear skies and precipitation. People plan outdoor work, travel, and events around forecasts that track these fronts. Infrastructure such as storm drains, levees, and reservoirs helps manage runoff and reduce the risk of flooding. The variability of weather in these regions encourages detailed forecasting and long-term planning. Coastal areas often receive rain when moist ocean air meets cooler land. This interaction creates clouds and precipitation that can occur regularly, especially in places with maritime climates. In regions like the Pacific Northwest, frequent light rain supports forests of evergreen trees and moss-covered landscapes. Residents become accustomed to steady drizzle, adjusting clothing, transportation, and daily habits to accommodate frequent wet conditions. Mountain regions experience rain in a different way. When air masses encounter high terrain, they rise and cool, releasing moisture on the windward side. This process creates lush environments on one side of a mountain range, while leaving the opposite side much drier. Communities on the wetter slopes rely on abundant rainfall for agriculture and hydropower, while those on the drier slopes depend on irrigation or imported water. The contrast between the two sides can be dramatic. Urban areas face unique challenges related to rain. As cities grow, paved surfaces reduce the ground's ability to absorb water. Stormwater systems must handle large volumes of runoff, especially during intense storms. Some cities incorporate green roofs, permeable pavements, and rain gardens to manage water more effectively. These features help reduce flooding and improve water quality by allowing rain to filter through soil and vegetation. Urban planning increasingly considers rainfall patterns as part of long-term sustainability efforts. Across the world, rain continues to influence how people live, work, and plan for the future. Each region responds to its own climate, developing practices and infrastructure that reflect local conditions. The variety of rainfall patterns creates a wide range of environments, from rain-soaked hillsides to arid deserts. These differences contribute to the diversity of human experience, connecting communities to the weather.